the next topic is recursion. And I just want to show you a pattern that many of you would have seen during our field trip to UT. And it looks like this, I think, if I remember rightly. So the idea is that you add 2 blocks to the ends of the major axes of the shape for each frame, and then you fill in the corners so there's a staircase pattern around the outside like this, etc. And there's a bigger one. And the question was, what is the pattern? And you look at it for a while and you think, okay, well, let's see if we can add something or multiply something to get the next term. So it looks like we add 4 to the first term because there's 1 here and 5 here. Okay, let's see if that works out to something. Okay, and then to the next one we add 8. Well, we have to just check and see if it works for the one after it. So I'll sketch the one after it and see if it looks reasonable to assume something like 12. Okay. Yep. So it looks like we have, okay, 1 here, we have 5 here, we have 13 here, and we have 25 here. Yep. So we then add 12. Okay, there's a pattern. So what do you do to each term to get the next term? Well, a lot of people figured out something like the following. You take the term before and you add 4 times that term number. So you add 4 times 1 here to get term 2. You add 4 times 2 to term 2 to get term 3. You add 4 times 3 to term 3 to get term 4, etc. And it looks something like this. Okay, this is not a subscript, this is a subscript, so is that. Another way you could do it, so this says to get any term, you take the term before it and you multiply 4 by whatever the term number of the term before was. So let's call this term 1. Here's term 2. Here's term 3. Here's term 4. Etc. Okay. So to get term 4, for example, we take term 3 and add 4 times 3. Okay, because 4 minus 1 is 3. So I'll do that as an example. Okay. Term 4 equals term 3 plus 4 times 3. Right? That makes sense. 25 is equal to 13 plus 4 plus 12. Yep, that works out. Alright, so this is good. Sometimes you see this represented as a relationship between maybe the next term and then the previous term is term n, and then you multiply by 4. Oops, pardon me. for n. Okay, this is the same as that. You're just kind of shifting everything up one term. So you might see that as well. This is great. This tells you what you have to do to any term to get the next one. Let me just start a new page. So the problem with a recursion formula is it's not very good for dealing with questions like this. Can you see what the problem is? The problem is that we actually don't know how many squares were in term 99, so that will make it very difficult for us to get to the next term, which is term 100. So we need a general rule. We need a rule that will tell us the output for any input. We need a rule that will tell us how many squares are in any term in this sequence. Another name for this rule is the following, not surprisingly.